Hello everybody, today we're going to be solving square root equations. So go ahead and open up your foldable. So we're going to start with some really basic, just square root, whereas once we go inside here, we're going to have some rational exponents that involve square root, but we're going to start with just plain square root. So this is basically a reverse PEMDAS problem, and let me actually zoom in. So this is basically a reverse PEMDAS problem. So we want to get this radical, the square root by itself. So I'm going to write my PEMDAS over here. So I want to start by adding or subtracting anything that is not in the parentheses. And I've got a 2 here that I can cancel out. So I'm going to subtract 2 from both sides of the equation. And then there's nothing else to add or subtract that is outside the square root. So then I'm going to move on to multiply and divide. And I see that I can divide by 2 because that 2 times is outside the square root. So I'm going to divide by 2 on both sides of the equation, which gives me the square root of 3x plus 1 equals 10. And then at this point, I'm actually at the exponent step at this point. Remember that a square root is an exponent of 1/2. So basically this right here is the same as 3x plus 1 to the 1/2 power. They mean the same thing. It's just two different ways to write it. So we need to go ahead and cancel out our exponent now. And so remember, before Christmas, you guys have actually done this before. To cancel out an exponent, you need the reciprocal of the exponent. And the reciprocal of 1/2 is, of course, 2. So we're going to square both sides. Let me do it here. Okay, so 3x plus 1 equals 10. That's what I had. So I'm going to square both sides. The square cancels out the square root, or in this case, if you were looking at it this way, those would cancel each other out. Either way, you are left with 3x plus 1 equals, and 10 squared is 100. So we've just taken care of our exponent step right there. And then finally, continue solving for x using first PEMDAS. So we're in the parentheses step now. And so I want to subtract 1 and then divide by 3. So minus 1, 3x equals 99, and divide by 3 on both sides. And we get x equals 33, which you can't see. No, you can. So x equals 33. Whenever we do square roots, it's a good idea to go back and check and make sure that your square root is not going to have a negative number inside it, because we are using real numbers here, not complex or imaginary. So if you put 33 in for x, 3 times 33 is 99, plus 1 is 100. Square root of 100 is 10. 2 times 10 is 20, plus 2 is 22, so it works out. Okay, so on the inside we have a few more. Now the only difference here is that we have not just the square root, but we have some other exponent as well. But the steps are exactly the same, and they're just like you did before Christmas when we solved equations with those rational exponents. So you've actually done this before. So hopefully this jogs your memory. So first, add or subtract anything not in parentheses. Okay, cool. Let's add 7, because that's not in parentheses. So 2 times x minus 1 to the 3 over 2 power equals 16. Then there's nothing else to add or subtract to cancel out that's outside parentheses, so we're going to keep going. The next thing we want to do is multiply or divide anything not in parentheses. So the only thing left out here is the 2 times this right here. So I'm going to divide by 2. And then I have x minus 1 to the 3 over 2 power, and leave some space for your swell. Yeah, we'll rewrite it. Equals 8. So x minus 1 to the 3 over 2 power equals 8. So what we have so far. So as we actually, let me go ahead and keep track up here. So we did add, subtract. We did multiply, divide. Now we're on the exponent step, and sure enough, cancel out the exponent using its reciprocal. So the reciprocal of 3 over 2 is 2/3. So let me first rewrite my problem. Here's what I have so far, and leave yourself some room right there. So I want to raise the whole thing to the 2/3 power on both sides of the equation. And these exponents cancel each other out. Now, a mistake that some people made on the midterm exam was that they multiplied everything by this number. You're not multiplying everything. This is an exponent. So you're only multiplying the exponent. And those cancel each other out. Okay, so exponents work with exponents, not with whatever's down here, not with the base. So I have, let's see, x minus 1 equals 8 to the 2/3. And by the way, 8 to the 2/3 is 4. So I have x minus 1 equals 4. And I did that in my head by doing cube root of 8 is 2, since 2 times 2 times 2 is 8. And then 2 squared is 4, but you could also just put that in your calculator. And you get 4. Continue solving for x using reverse PEMDAS if necessary. So all we have to do is add 1. And I get x equals 5. Yay. So I have x minus 27 to the 3 over 2 power equals 64. So I want to use reverse PEMDAS. And I want to start out by adding or subtracting anything that is not in parentheses. And I don't know why it's blurry again. Stop being blurry. Okay. Now, outside the parentheses, there's really nothing. So there's nothing to cancel out using addition or subtraction there. Same for multiplication and division. There's nothing outside the parentheses that I can cancel by multiplying or dividing. So I'm just going to keep moving up. Now I can cancel an exponent. I can cancel the 3 over 2 exponent. So let me rewrite it. Okay, so I need to cancel it with the reciprocal. Reciprocal of 3 over 2 is 2/3. So take both sides of the equation to the 2/3 power, which cancels the 3 over 2 and the 2/3 cancel out because they're reciprocals. Again, you're multiplying the exponents together. You're not multiplying the base times the exponent, so be careful. That leaves me with x minus 27 equals, and that would be 16. Again, I did cube root of 64 and then squared it, but you could also put it in a calculator. And then add 27 to both sides. So actually be 43. Okay, number 2. Again, I want to do reverse PEMDAS. So can I add or subtract anything outside parentheses? I sure can. I can subtract 1. And in case you can't read that, that's 3 over 2 again. Okay. So there's nothing else I can cancel with addition or subtraction that is outside the parentheses. So I'm going to move on to multiply and divide. And I can cancel that times 5 by dividing by 5. So I'm going to do that. So I have 4x plus 17 to the 3/2 power equals, should be 729. All right, and then there's nothing else to multiply or divide outside parentheses. So I'm going to move on to the exponent step. And I want to cancel that exponent with its reciprocal, which again is 2/3. So let me rewrite it. And take both sides to the 2/3 power. Okay. Again, 3/2 and 2/3, they're both exponents, so they cancel each other out. So 4x plus 17 equals, and that is 81, I believe. Okay, so then I just have a linear equation left. So I just subtract 17 and then divide by 4. Scoot this up a little bit. So minus 17, 4x equals 64, and then divide by 4. A little bit different. These don't have square roots in them. They have fourth roots. But again, you're still using the same process. It's just like you learned before Christmas. Okay. So start with add and subtract. Go and write it up here. Okay. So I can add 3 to both sides. And then is there anything else to add or subtract that I can cancel? No. Anything to multiply or divide? No, not outside the parentheses anyway. There's a 2 in there. So I'm at the exponent step. I need to cancel the 5/4. And remember, you cancel the exponent with its reciprocal. So I'm going to use an exponent of 4 over 5. So 8 minus 2x to the 5/4, and then leave yourself a little bit of room, equals 32. And you're going to raise both sides to the 4/5 power so that your exponents will cancel because they're reciprocals. So it leaves me with 8 minus 2x. And those canceled equals, and then 32 to the 4/5 should be 16. Again, you can put that in a calculator. Or do it the way I do it in my head. 2 to the 5th is 32, so I have 2 to the 4th, which is 16. All right, so now we're inside the parentheses, so we start back at the bottom. So is there anything I can add or subtract to cancel? Yes, there is. There's an 8 right here. So to cancel out positive 8, I subtract it. And then finally divide by negative 2. And finally, last one, but not least. So add or subtract anything? Yes, I can cancel out that negative 1 by adding 1. So I have 27x to the 3/4 this time equals 27. So I've done that. Can I multiply or divide anything to cancel outside the parentheses? No, there's nothing else. All I have left is the exponent in the parentheses, so I'll have to do that. Then I want to cancel the exponent. So use its reciprocal. So this is 3/4. So I want to use an exponent of 4/3 to cancel it. So I'm going to rewrite it down here. There's my 4/3. Okay, so I raised both sides to the 4/3 power. 3/4 and 4/3 are reciprocals, and they're both exponents, so they're going to cancel each other out. So then 27x equals, and then 27 to the 4/3 is 81. And then finally divide by 27, which gives you 3. And once again, just double check, make sure it comes out positive. Yes, it does. Yahoo.